Welcome to this explainer. Today, we're going to completely shift how you view the frontier AI race. Because right now, so much of the conversation out there is just totally fixated on which model is technically the smartest. But the real contest? It actually isn't about that anymore. It is fundamentally about which system can build a stable, governed intelligence infrastructure. We're talking about a massive shift from just, isolated models to an entirely new operational paradigm.
So let's just dive right into this by ascending the operating stack layer by layer. We'll be moving through beyond the chatbot, compute as directed power, memory, code, and agents, the organizational phase change, governing recursive R&D, and wrapping up with intelligence as governed infrastructure.
All right, part one, beyond the chatbot, task horizon capability. We really have to look past the standard chatbot interface to understand what's actually happening here. It's all about the shift toward the task horizon. Think of it like the difference between, say, answering a quick trivia question versus managing a complex, week-long corporate project. Short horizon systems are super simple, right? Context enters, a response exits, and the intelligence basically just dissipates. The loop ends. But long horizon systems, where an AI works independently for hours or even days, they absolutely cannot operate that way. The longer a task stretches, the more room there is for drift, so they require major load-bearing structures. They need to persist state, rely on memory filters, hit stop conditions, and respect strict authority boundaries. They have to route attention and actually correct their own errors just to maintain coherence over time.
Moving to the next layer, part two, compute as directed power routing. When we look at the physical realm, it becomes incredibly clear that massive compute clusters are not merely, quantities of GPUs you can just tally up on a spreadsheet. Compute is directed power. These massive clusters concentrate experimental and institutional power, dictating exactly who gets to test and deploy frontier-scale systems. And because of that intense concentration, informal governance completely fails. The more energy a system mobilizes, the more it demands explicit deployment discipline and incredibly strong, risk-weighted governance.
Which brings us to part three, memory, code, and agents, the software layer. So moving up the stack, all that raw capability has to be routed through software. And there is a massive distinction between a long context window and true memory. True memory isn't just hoarding every single piece of information. Think of it like the difference between a disorganized hoarder's house and a meticulously curated library. Without discipline, an infinite context window just becomes a landfill of past tokens. Real memory is what the source calls governed compression. It's selective preservation, intentional forgetting, versioning, and causal explanation. That is what actually stores energy and makes decision logs auditable, which honestly is the only way to keep these systems from just aimlessly drifting off course.
Let's look at a really fascinating case study mentioned in our sources, the model mythos. We aren't just talking about an AI writing a quick, useful function. We're talking about deep code intelligence, an AI traversing entire legacy code bases, tracing hidden dependencies, and actually reconstructing human intent from old code. That releases massive diagnostic energy. But here's the catch. It's inherently dual use. Finding a vulnerability can be used to harden a system, or it could enable a devastating attack. Because of that, deploying something like Mythos requires incredibly strict access routing, ironclad disclosure protocols, audit trails, and a definitive repair-first deployment strategy.
Now, when we scale this capability up, we get into multi-agent work. And here is a crucial insight. Simply throwing multiple AI instances together does not automatically make a team. Without an explicit energy architecture, they just create duplicated work, or worse, false consensus. The outputs have to move through specific converters inside an energy routing network. So a proposal from one agent has to become a testable plan. A test failure needs to trigger a diagnosis by a critic, which is then checked by a verifier and ultimately logged by a memory manager. You absolutely must have explicit authority boundaries, shared state, and really clear role separation for this to work.
Okay, part four, the organizational phase change, productivity, compression.
This is where the intensity of everything we've talked about rises dramatically. Imagine a tiny 3-person team. Now, amplify them with highly coordinated AI. And suddenly they are producing the output of a traditional 300-person department. We call this productivity compression. But this compression creates a massive bottleneck because that tiny team is now pushing decisions through a corporate system at a rate that completely overwhelms traditional legal, security, compliance, and even just basic social adaptation systems.
And because of that radical productivity compression, the risks themselves mutate into system-level, long-horizon threats. If a small team can move faster than its own company's oversight capacity, those institutions literally have to redesign their control points from the ground up. We're talking about strict boundary rules, clear escalation protocols, and highly explicit human override capabilities. Without this total redesign, massive productivity gains are just going to collapse into organizational instability.
Section 5. Governing Recursive R&D. Epistemic Traction.
We really have to slow down here and look at the most consequential frontier: AI-driven research and development. When AI systems start helping to improve other AI systems, we enter a recursive feedback ecology, and there is a massive danger here. These recursive systems can start validating their own assumptions. They can optimize for benchmarks they help design or produce synthetic evidence way faster than humans can even evaluate it. To maintain what the authors call epistemic traction, which basically means keeping our grip on reality, we desperately need independent evaluators, rotating benchmarks that resist overfitting, structured failure memory, and vital external human intervention points at high-leverage decisions.
This dynamic perfectly illustrates why the contrast between organizations like Anthropic and OpenAI is framed by the sources as fundamentally a contrast in governance architecture, not just a generic, binary debate of safety versus capability. It's really about where risk actually enters the decision loop. A symbolic research institute might ask grand questions, sure, but if that doesn't ultimately change corporate action, it's really just reputational decoration. True operational governance actually changes release decisions. It enforces deployment thresholds, forms partnerships, and triggers emergency procedures.
Finally, Part 6, Intelligence as Governed Infrastructure, the full EP stack.
Now, transitioning to the macro layer, what's really crucial to understand is that the energetic paradigm should never be reduced to mere safety rhetoric. Control, the act of blocking dangerous actions, is absolutely essential, for sure, but it is merely one boundary layer inside a massive operational stack. The full stack has to handle deductive discipline, energy flow diagnosis, memory governance, failure compression, and trust architecture. The much larger problem is how the whole system preserves coherence, resists incentive distortion, routes its capability toward valid uses, and remains socially absorbable as it scales globally.
Ultimately, this global infrastructure must execute one central conversion chain. If you take away anything from this explainer today, let it be this: raw model capability only becomes durable, useful intelligence, when it is actively routed through governed memory, structured into coordinated agents, subjected to independent verification, and held to strict institutional accountability and controlled deployment. Break any single link in that chain, and the capability simply becomes fragile or worse, destructive. As we watch this high-contrast technological landscape unfold, transitioning from models as simple products to a globally integrated intelligence infrastructure, it's no longer a question of whether intelligence will scale. It will. The real defining question for the future of human adaptation is this: can scaled intelligence be disciplined, interpreted, governed, and integrated fast enough to remain useful to human civilization? It's a massive challenge. Thank you so much for joining me on this explainer. Keep questioning the infrastructure around you, and I'll see you next time.